Okay, for the base, we're going to do another revolve, but we're looking pretty much at this inside profile to generate our geometry. So let's go ahead and open up a new part and make sure that we're in metric. I'll go into the front plane, create my center line, vertical, infinite length, place it. I'll go back into the line. I'm just going to draw the outside profile. And then the inside profile, we have line to the threaded portion, and that's a little bit smaller. So bring that down, and then the diameter I'm not too sure about, and then that can come back to the center. Now, if we were doing this with the whole wizard, it would be a stack up of 2 or 3 different pieces of whole wizard features geometry. Missed the closing off, so hit L, go back in. Alright, so now we're ready to start adding some dimensions. The overall height is 100, and we'll start working on the diameters. And we have a diameter of 36. Alright, so it's not surprising that that would close in. So the choices are to make it a little bit bigger and bring the inside in first. So maybe I'll just do a Control Z, and we'll update that as we go. And to kind of make that work, I guess we should go from the inside to the out. Alright, so the depending on where we want the chamfer on the screw to contact this edge, and if it was a full block off, we'd probably try to put a matching chamfer in there. Let's see, we're 20 millimeters on the diameter of the thread, and if it was to go 3 millimeters smaller, we could see what it looks like at 16 or 17. And a standard thread is going to be 118 degrees. So we either have the half angle, okay, so going between those two would be 59 degrees. And even if this turned out to be a 135 degree drill point that we used, the 118 would be the deeper of the two. Okay, and then we'll go to an M20. We used an M20 by 2.0, so that would be 18. Right, so the minor diameter for a metric thread, M20, and we used a pitch of 2, so 20 minus 2 gives me the 18. And the outside was 22. Alright, we're ready to start putting in our height, so I'm going to hit escape and get rid of the diameter. And to the first step is, well, looks like we're going to do some math. So since these are in context, 21.5 plus 24 give me the step, and then to the next is 28. Right, and then this one was 4. So it doesn't quite look like my like the picture. A little thicker at the base. So we're gonna have to do some adjustment, or verification, I guess would be a better way of putting it. So 28 to the step, 4 to the base. Don't really have a point to work from, so we'll just have to verify it in the assembly. So the 21.4 was to the threaded hole, and another 24 to the step, and that does add up. And then between the steps, 28. Okay. So features, we will revolve, Oh, I guess it would have helped. Let's go ahead and accept. Would have helped if I had changed the outside to back to 36. So we'll identify the 66, change it over, and then we need to rebuild because I changed it on the fly. Okay, so we have two methods of creating a the whole wizard for the M6, and standard thread pitch would be by 1.0. So my first, if I go into the right plane and hold down the control button and click on the plane and drag it out, it's going to create an offset plane. And then I don't want a distance, I want it to be parallel, and my second reference will make it tangent to the face. So that gives me a surface that, or a planar surface that I can pick to apply the whole wizard to. Alright, so Ansymetric, tapped hole. We're going to go back up to the M6 by 1. It's going to be an up to next and up to next. Those look good. So if I place it above the origin, then I can pick for vertical. And we said that the first would be to 21.5. Okay, and accepting it, and that gives me my geometry. I can right click and hide the plane. Now if I don't pre-select and we just go into the whole wizard, this is where the 3D sketch comes in. So same geometry, same settings, but when I go into positions, if I click on the 3D sketch, I'm actually putting it on that face. So now I have a completely different set of relations that I'm going to be working with. So I need to find the front plane and the point. It's going to let me have it. Okay, let's grab the point and then the front plane, and that can be on plane, and then from the top to the point, 41.5. Alright, so that may look as easy, and it has there are places where it has advantages. The problem is with it on that surface, this is going to be able to rotate and go in quite a few directions, and you're going to have to manage that 3D sketch a little bit closer. So until you get a good level of comfort with the 3D sketches, I tend to stay away from those. So let's go ahead and save this. And then this is going to be the base. We'll save. And don't see any geometry or anything that I missed, so we'll go ahead and accept this.